So hi, how are you, Raj? All good? Yeah, I'm also good. Hello, sir. Hello, madam. How are you all? Great. I'm also well. Thank you. So, Raj, my name is Manish Singh, and I live in Prayagraj. I have done my BTech from IIT Hamirpur, Himachal Pradesh in 2016. My branch was mechanical, and also, I have experience of 5 years as a physics and maths tutor in companies like Sathi, IIT Kanpur project, and Arcade Craft. So I hope that you find this session very fruitful for you. And for the introduction of this session, I will tell that it is about measuring instrument that is vernier calipers. So Raj, have you heard about this? What is vernier caliper? No? Okay, no issue. I will tell you in this session what is the vernier scale and what is the main scale, how to take the reading from vernier calipers, and what are the zero errors in this. Okay, so let's start the session. Yeah. So first of all, Raj, I want to ask you that what is your expectation from me and what you want to become after this 10 stream, what you want to take the stream and what you want to become in the life. Okay. You want to become engineer? Thank you very much. That's great. And what are your expectations? Yeah. So I will try my best to give you the proper explanation of this session. Okay. So let's start. What is vernier calipers? So Raj, see, vernier caliper is a measuring instrument. In ancient times, there was a misconception of that we cannot read below some reading, but vernier calipers was then found out by scientists, which can read up to point zero one like this readings, point zero 0.02, point zero 0.03. Earlier, it was only possible to read point 0.1, point 0.2, point 0.3, but vernier calipers were discovered to read readings like this. Okay, so let's start the session. Uh, we will move to the next slide. This is the diagram of vernier caliper. I will explain the components of this. Okay, don't worry. Okay, so see here, this is the terminology of vernier calipers. Okay, so this upper part is what? Upper jaws for inside measurement. Suppose you have to measure any object like this. You put it here and you can measure this dimension. Okay. Lock screw is for locking the reading. Main scale, this upper upper scale is called main scale. Okay. You can take reading from here also. And this is below one is vernier scale, which will help you to find out the reading two after two digits before decimal. Okay, so that is the main thing of this. This is thumb screw where you can push and pull your reading, and this is depth rod. Suppose you have to measure any depth of any object, so you can plug it here and you can take the reading. This is lower jaws for outside measurement. Suppose you have to measure this outside reading of any object, and it is lower jaws for this outside measurements. Okay. I hope you got this, that what are the components of the vernier calipers. Okay. Let's move to the next slide. Yeah. So what is the least count of vernier caliper? I think that you are aware of least count. What is the least count, Raj? Yeah, you are correct. The minimum reading that an instrument can measure. So what is the minimum reading here? The minimum reading must be equal to main scale reading minus vernier scale reading. That is of division of there. This is the main scale division and vernier scale division. The difference of this is what? One and one is what? One. What is that? Least count of vernier calipers. Okay. Yeah. So what is the one MSD here? See here, this whole reading is 1 centimeter and it is divided into 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what is the least count of main scale? Main scale least count is zero point 0.1 centimeter. Okay. That is 1 by 110. That is the division. That is equal to 0.1 centimeter. And what they see here, that vernier scale has no units written here. So you can see that 0 is coinciding with main scale and vernier scale. And also the 10th reading of vernier scale is coinciding with what? Ninth reading of main scale. This means that 10 main vernier scale division is equal to 9 main scale division. This means that one-year scale division must be equal to 9 by 10. And what is the mean scale division? Zero point 0.1. So right here, 0.1, that is equal to 0.09 centimeter. So what I have calculated here? Here I have calculated the one vernier scale division reading, that is equal to 0.09 centimeter. See here, it can measure up to 2 digits after decimal. Okay. So what is the least count of vernier caliper? Must be equal to 1 MSD minus 1 VSD, which is coming out to be zero point 0.1 minus 0.09, and it is equivalent to 0.01 centimeter. See here, we have just formulated it to 0.01 centimeter, 2 digits after point. Okay, so let's move to another slide and see that how to measure the reading. Okay, reading of under calipers. See here, suppose your reading is like this. So the object is placed here like this, and the reading is coming out after this. So 2.1 is the main scale reading. 2.1. Here 2.1 is the main scale reading, and after this distance is to be measured. Okay, this small distance, this one. So what is this reading? This reading is, this distance is y, and this distance is x. And y is the distance y is on main scale division. Main scale division, it is y, main scale reading, and the vernier scale reading is x. So when you subtract it, so what will be the reading? Y minus x. This will be the smaller part reading that is we cannot calculate by naked eyes. So this is what smaller part reading. What it will become for a main scale reading? It will be here the fourth division is sorry, the third division is matching here, no? The third division is matching. So we will write 3 into zero point 0.1 minus 3 into 0.09. What will come? 3 into 0.01. That is equal to 0.03. Okay. So what is the complete reading? Complete reading of one year calipers is 2.1 plus 0.03. That is equal to 2.13 centimeter. I hope you got it, Raj. Any doubt in this? Okay, you have a doubt that how I taken y and x. See, I will show you by drawing. Suppose this is your main scale 2, and this is 2.1, and your one-year calipers is coming out here. Your one-year caliper reading that is coming out by one-year scale is here. So you have to measure this small distance. Okay, this small distance is what? If I measure here from what is coinciding with the one-year scale, so this is coinciding third division, and 1, 2, third division, and here also it is coinciding with what? 1, 2, 3. Okay. So if I calculate this distance, this one distance, that will be equal to y. And if I calculate this distance, it will be equal to x. And after subtracting it, do you can see that here I will get y minus x equal to the small unknown reading. Okay. So that is how we have got this. Okay, the reading of this measurement. So I think that you have got this, Raj, now. It is little bit confusing, but I know that you can got it. Okay. So let's move to the next slide. So what is zero error of one-year calipers? So zero error is what? Suppose you have a reading that is in the right hand side. If we align both one-year scale and mean scale, and the zero is not matching. Suppose its zero is here and its zero is somewhat here. So this is not matching. So what will be it? If I calculate some my reading is like 2.1. Then I have to minus this one reading, this small reading, minus 0.03. So that will give the exact reading of this. So what is the formula for positive error? How I manage this? You got it? Like if you see Milskin reading minus your error. Okay. Okay. This is sorry. This is 1 year scale rate, 1 year calipers reading minus error. Okay. So that is how the positive error is calculated here. Now let us move to the next slide. Similarly, there is negative error. Negative error is what your zero is matching with left hand side of zero of main scale. So one scale is here and main scale is here. They are not coinciding, and it is some extra reading is there where that is in minus side. So what we will have to do if my measured value is 15.3, then I have to 15.3 add the this one reading, this much reading. So this is what plus suppose it is 0.03. So that is the correct reading. So what is the formula for this? Correct reading is equal to mean reading minus of negative zero error. That is equal to 0.03 here. So it will come out like this. Mean reading plus 0.03. What I have done here also. So you can see here, if there is imbalance in the zeros of main scale and vernier scale, we have to measure it like this, what I told you. Okay, I hope you got it, Raj. Okay. So after this session, I want to ask Raj that how was my session, and please rate it out of 5. That if you liked it, then please write it here and give the ratings. If you don't like it, you can also told me. And if you want to see the replay of this session, then you also need to rate this session. So I hope that you have liked this session. And if you have any doubts and any type of concern, you can ask our team. Okay. And I want to talk to your parents also. Yeah. Thank you. Thank you. Yes, ma'am. So I am telling that, ma'am, how you like this session and what are your expectations from our side? And if any doubt, you can ask from us. Okay, okay. You liked the session. Okay, ma'am. Okay. Thank you, ma'am. Yeah, it is little bit confusing, ma'am, but if you replay it and see it, or you can ask for more videos from us, then it will be beneficial for you. It will be as clear as much you can see it. Okay. So yeah, ma'am. For discounts, ma'am, you can ask to our academic coordinator. They will revert you back of what are the discounts and what things you need to know about us. Okay, ma'am. So yeah, we will really work hard for your child, and there are some the practices issues for him. So we will make him to practice also, so that how he will get to encourage himself and will be motivated from us. So that's all from our side, ma'am. Thank you and have a great day.